control structures. So algorithm, it consists of modules and the logic of the program, right? So mostly the simplest programs now we will be just writing line by line to be executed without any change of flow of control, right? Sequence logic. After this line, go to the next line. Like that, no? That will be our sequence logic. But if you want to go for a little more useful program or smaller program, you will be writing with the iterations, right? Or you will be using some selection logic, or you will be using some repetitive iterations and all. So you can write the program either in the sequence manner, that is sequence logic, or you can go for the selection logic. And one more is like a repetitive logic, right? So we'll first see, we saw that sequence logic already. After that, we saw the selection logic. That is nothing but our if else if statement. Got it? So we are not writing with the syntax of only the C language. Algorithm should be written for which is applicable for all the programming languages, right? So we cannot write logic with using the syntax of only C program or only Java program and all. So we are just seeing the terms which we are going to use when we are having we are writing an algorithm, which is common for an algorithm which is common for all the programming languages, similar programming languages. So you can have sequence logic. The second type of logic is known as a selection logic. So depending on its particular condition, that particular module will be executed. That is known as selection. Selection means either true part or the false part, or we have many conditions. I had shown you single alternative, double alternative, or multiple alternative. Single alternative is nothing but our if condition with only the true part. If this condition satisfies, then execute these lines of statement. We don't have any else part. But double alternative is like if you have if condition satisfy, execute this part. That will be the true part, and then you will have an else part. In else part, we'll have another set of lines statements to be executed if the condition is false. True part and false part. That is double alternative. The third one is multiple alternative. In multiple alternative means there will be many conditions and there will be many statements, pertaining to each of the condition if it is satisfied. Got it? So you will be writing it with the else if ladder. If one condition is satisfied, this statement has to be executed. Else if this condition is satisfied, execute these lines. Else if this condition, likewise you using switch case also. Switch case also, if case 1, then execute. If case 2, execute this. That is both example for multiple alternative. So we finished sequence logic, which is the simplest. Second one is selection logic, depending on a particular condition. That is like our branching statement. And now the third one is a iterative logic or the repetitive logic. For that we studied the branching statements for loop and while loop, right? So in if loop, for loop and not, while loop and for loop and not, you will be repeating a body of loop, right? Or a set of statements or a block of statements controlled number of times. Got it? You will be using a for loop or a while loop with a control variable, or in while loop it will be a condition. In for loop it will be a control variable, and you will execute the body of the loop these many number of times, a controlled number of times. That is known as an iterative logic or repetitive logic. So in this, if you are using a for loop in certain conditions, it is better to use a for loop. Both for loop and while loop, we studied about the entry control and exit control and all, right? Do while. So we are just showing the both with the entry control loop. Mostly we will be using only entry control loop, for loop and while loop, when we are writing the syntax or when we are writing the algorithm. So in we will not write with the syntax of C for loop. We'll write in the algorithm the repetitive. If you are using for loop, if you are planning to use a for loop, that we'll be having, in for loop we'll be using a control variable I, right, to control the loops. What is the difference between for loop and while loop? Both you will be using, both are example for entry control loop, right? But in for loop, you will be using a control variable. Sorry, for I equal to 0 to I less than n. I will be the control variable. I determines how many times the loop has to be executed, right? That means in for loop, it is a repetitive loop, but we are using a control variable to control the number of times the loop has to be executed. But in while loop, and while loop, what you will do, you will use a condition to control the loop. So instead of so there is a difference in writing the algorithm when we are using a for loop and the while loop. That's all we are using here. Repeat for loop is a syntax or the line which will be indicating in an algorithm to indicate that we are going to use a for loop. So repeat for I equal to s to e. We are not using for I equal to 0 to I less than. That is the syntax what we are using in C program, right? So we are not using like that. In algorithm, as I told before, we will not using any syntax. This is a syntax for loop. I equal to 0 to I less than. But the syntax of writing for loop may be little different in other programming language. So we will be just generalizing and showing that repeat for I equal to S to E. S indicate the variable which is the start value and E indicate the end value. In this sentence, Mrudula, can you tell me which is the S value and which is the E value? Which is the S value and which is the E value? In for I equal to 0 to I less than n. Mrudula, are you there? Mrudula. Complete silence. You can keep your mic on. No need of muting. Only 12 students are there, right? Mridula, I'll mark everyone absent. Nagraj, Nagraju?
Yes, ma'am.
Tell,
Ma'am.
Mridula, I'm marking you absent. Not even yes, ma'am. Tell me which is the S value. S indicate the start value and E indicate the end value for loop. So in this
Yes.
statement, which is start value of I for the for loop?
S is for instead of I, we can consider S now, ma'am.
No, no, I'm just showing that S is the start value. What is the start value of the control variable I? 0. Okay. And what is
Yes,
the
yes, ma'am.
end value for the control variable? Control variable,
Eh,
which is the
le-
variable? I is the control variable, right? Start value is
yes, ma'am.
0. End value is less than n means
N.
1.
N.
Got it? So
N.
here we are indicating in the like we are using a control variable in for loop. Now we will be using a control variable with one start value and one end value. So and then each time we'll be incrementing by t. In when you write the for loop, you will be writing for I equal to 0 to I less than n I plus plus, right? So I plus plus means what? I plus plus means what? Harsha, can you tell me what is I plus plus?
Incrementing.
Uh, Incrementing, Nitin is answering. So here I plus plus means I is incremented by 1, right? That means this will be the incremented. Each time it is incremented by 1. So T is the increment means here this case T is 1. One time, one value, no, I value is incremented by 1 means 1 is the increment. If you are giving like I if you want to increment in I by 2, then you can just give I equal to I plus 2 also you can give, right? That also you can just give. What we were giving as a short form, I plus equal to 2, right? Now, the next type where we can write the while loop. Some places we can go for repetitive loop of using the while loop. So what the difference between for loop and while loop is when you write in the algorithm, repeat while and then you have to write condition. Here when you are using for loop, in such cases, no, you can just indicate we will be using a control variable which is controlled by the initial value and the final value and by the increment. But when we are using a while loop, repeat while and then indicate the condition, the module to be executed and then the end of loop. Mostly the line to be executed now, that is known as a module. Okay, then you will be writing end of the loop. This is only to understand the syntax of writing an algorithm. We were writing programs, and last semester we have written many algorithm, right? They have given this topic in your syllabus. That's why I'm taking. Okay, nothing serious. Control structures, how to indicate, and preliminaries, that chapter indicate how the terms which are used in an algorithm, they are just explaining in the beginning. So this is all what we studied, and we also wrote many algorithms and programs. Now in this semester, they are just showing how to neatly write a program, write an algorithm, considering all these, if you are using a for loop, you have to write repeat for I. And if you are using a while loop, you have to write repeat while condition. More specifically, they are doing. The looping continues until the condition is false. If the condition is true, then it will execute the lines. Here it is like it will execute the loop from the initial value to the end value. Each time it will be incrementing the control variable by t. It's nothing but our for loop. Now we are moving on to the actual topics which are important. So here, as I told, the main thing is you have to understand about the algorithm. Algorithms we studied last semester. It's nothing but the same definition and figure I think I had kept in the last semester also. It's a set of instructions which are given to the computer, and these instructions should be finite. It should not be a never-ending algorithm, right? Actually, you should tell me what is an algorithm. Pavan, can you tell me what is an algorithm in simple terms, not as a definition?
Algorithm is a step-by-step representation of a problem.
Uh, how to solve a problem, set of instructions, step-by-step instructions, how to solve a problem, right? So it will be a finite set of steps, and it should indicate how the program has to be, it should be applicable for all such similar problems. Okay, one solution should be given for all similar types of the problems, right? So, and it should be finite, and we should be defining what should be the input, well-defined input and well-defined output, what we are expecting. This is the input what we are giving, and this is what we expect. And these steps should be clear and unambiguous. Ambiguous means it is not clear. Unambiguous means it is clear. Don't get confused with that unambiguous term. You can just write clear, and it should be language independent. I told no, it should not be pertaining to any of the programming language syntax. It should be independent of the language, and it should be finite, and it should be feasible. You should not write some steps which is not possible to execute. So this defines the algorithm. Algorithm is a well-defined step-by-step instruction for solving a particular problem, and then you can write the characteristics of the algorithm also. So algorithms are used to find the best possible way of solving a problem. Why we are writing an algorithm? To solve a problem. Why we are writing a program? First, initially we will write an algorithm, and then we will convert that into a program, right? So main aim is to solve a problem. You will have a problem, and you're going to solve that problem using these steps, right? Now, so this algorithm, depending upon one example, I'll just explain. After explaining with this, we have already completed linear search and binary search. 1 second. Hello. We will learn one more term. We have to study about an algorithm. So we are going to learn it using an example. Yeah, last semester we studied what is an algorithm. So in this semester, we are going to understand more about an algorithm, why we need to have different types of algorithm. When I am given a problem, I will be solving in a manner. And if I'm giving that same problem to Meenakshi, she will solve it in a different manner, right? So there will be different ways for solving a problem. I will argue that, or I'll try to justify that my algorithm is best, right? But she will try to justify that this way, this mine is better. So like that, many, for our example also, I'll tell you linear search and binary search, both are for searching a number in an array, right? Number in a set of a particular number, we are searching and returning the position. But why we need to have both linear and binary search? And as I again told, we have different sorting techniques. Yeah, so few of them, no, I can just list out the normal sorting, what we are doing, bubble sorting, and then insertion sort. All these, no, we'll study in the semester. Quick sort and merge sort. Many sorting techniques are there. So why we need different sorting methods? So and each time, no, those who are writing the algorithm or finding a solution to a particular problem. Our problem is what? In linear search and binary search, what is our problem? To find the position of a number in a set of numbers. That is our problem. I need to find the position of this number. That is my problem. And sorting, what is my problem? I want to get the elements sorted in ascending order. That is my problem, right? So you will be given a set of numbers which is not sorted. After execution of this algorithm, I should be able to sort the elements in ascending order or descending order. Got it? So for a particular problem, I need to find the best possible solution and which is taking. So how to compare best possible solution? Both of us, we will tell mine is best and she will tell mine is best. But how to check in terms of a proper condition, that is like we have to justify with a proper proof. In max we will have no proof should be there like that. In algorithm also we should be showing with the proof that this is far better than the other algorithm. Got it? So in order to understand that, I'm just showing the linear search algorithm. And one more thing is, in this, no, they are showing it as an example for writing an algorithm with the proper steps. So we already studied in the last semester how to write an algorithm. So as I told in the previous slide, input and output of the algorithm should be clearly defined. So in sequential search or the linear search, this is the algorithm which I'm going to write for linear search. A linear search is also known as sequential search. In suppose in question paper they ask to write the algorithm for sequential search, you should write the same algorithm. Linear means and sequential means linear. Okay, so a linear search or sequential search, first you have to give the heading algorithm sequential search. After that you have to give the input and output. What is the input expected, what is output which you are going to get. So algorithm will be a particular algorithm will be working only for a particular. If you are not giving a set of numbers, this algorithm will not work, right? So we are telling that informing the user that if you are giving an array of numbers and if you give me the size of the array and the search number, these are the inputs which we are expecting for this algorithm to work. Got it? If these are the inputs, then my algorithm will be working. And the output, what is that output? I am claiming that it will be producing from this algorithm. It will return the index of the first element, which index of the first element which matches with the search element. If you have the search element as 2, and I'm having in my array 2 times the search element 2. I have 2 coming over here in the first position and somewhere else, I have 2. So it will be returning the position of the first number which is equal to the search element. Got it? So, and in case 2 is not present in the array, it will be returning a -1. If the element is not present, it will be returning -1. Like that, I have written my algorithm. Got it? So this will be the expected input, and what is expected or what will be the output. The output will be index of the first element A that matches with the search element, or if the element is not present, then it will return a -1. So like that, I have written my algorithm. And step 1 is initialize I equal to 0. And then in step 2, I have given repeat step 3 while. And then here in this, I'm planning to use a while loop with the condition mentioned in the bracket. While I less than n, and 2 things I'm checking using an and. I less than n and a of I is not equal to s. So what are these 2 conditions? Can you tell me in simple words? Meenakshi, can you tell me? What are the 2 things which I'm checking in this while loop? Meenakshi?
We are checking whether the control variable I is less than the array size.
Okay.
And you're checking whether the number is present or not, ma'am, like at the index number A at I.
Yes. So we are checking 2 conditions. If any one of these is not satisfied, then you will not execute step 3. Got it? If both the conditions are satisfied, then only you have to execute step 3. Got it? So initially we initialize I as 0. So this condition you check I is 0 and 0 is less than n. In our case, suppose I am taking this array. What is the size of the array? Vinod, can you tell me the size of the array?
Yes, ma'am.
What is the size of this array, which I have shown in this example?
8, ma'am.
8 or 9? 8 is the index.
9.
You count and see, it is 9, right?
Yes, ma'am. 9.
Index number is starting from 0. That's why it is ending at 8. So the size is what? Size is 9. Got it? So you are checking whether I is less than 9. Yes, 0 is less than 9. And then suppose a search element. Search element I am getting in a variable called s. S is equal to 20. I am going to find the position of 20 in this array. Got it? So what is A of I? When I is equal to 0, what is A of I? Vismaya, what is A of I?
0, ma'am. Like 10.
10, correct. So A of 0 is 10, right? So we are checking whether A of 0 is equal to S. A of 0 is 10 and S is equal to 20, right? If it is not equal, then we have to. So these two conditions, if any one of these are not satisfied, then only we have to, or if both the conditions are satisfied, only we have to move to the step 3, right? So what is in step 3, we will see. We are going to increment I value. So what is the meaning? If you are finding what is A of I not equal to S, what is A of I not equal to S? If you are not finding the search element. If you are replacing this exclamation symbol with a W equal to, what does it mean? A of I is equal to S. In our condition, A of I is 10 and S is 20. That means it is not equal to. If it is not equal to and I value is not, and if I value is less than n, what you have to do? We have to increment the I value. Initially, I value was 0, right? We are incrementing I value by 1 means what will happen now? I value will become 1. So 1, again we will check 1 is less than n, right? And 1 is less than n. And what is A of 1? What is A of 1? Mamta? What is A of 1?
50.
50. So A of 1 is 50. Again, we are checking whether it is not equal to S. What is S? S is 20. 50 is not equal to 20. Both the conditions are satisfied. Again, we will increment I. So this will continue until any of these, no? So we will be keeping on checking and then we will be incrementing I each time. So we are asked to repeat step 3 until any of these conditions are not satisfied. So always, we will be incrementing I, and when it comes to this position, right? So when it reaches I equal to 5, and then we will again check when I equal to 5, what is the value of A of I? A of I 60, it is not equal to 20. Then again I value will be incremented. Then I value will become 6. 6 is less than n, correct? 6 is less than 9. And then what is the other condition? A of 6. What is A of 6? Mrudula, what is A of 6?
20.
20. So A of 6 is 20. So it is not satisfying this part. This is correct. 6 is less than n and 9. But the thing is, A of I is not equal to, as that condition is not such, because A of I in our case, it is equal to 20. S is 20, A of 6 is also 20. Then what we have to do? We should not execute step 3. It will move to step 4. Now we are checking if I is less than n, return I as index number. There will be two conditions when we come out of this while loop. One condition is I will be greater than n. The other condition is if A of I is equal to S. So in order to check whether we have actually found the element, we are checking with this condition. If the index number is less than the size of the array, that means we found the element. That's why we came out of this while loop. Return I as an index. So this way, we can write a crisp algorithm. I have given another algorithm for linear search, which is a little more longer. That is the actual program what we have used here. We are checking both the condition over here and then returning the index if the index number is less than the size of the array. So in case if it is not less than the size of the array, that means we have come out of this while loop because of this condition not satisfied. So we will be returning -1. We searched throughout the array and still we didn't find the element. If 20 is not present, suppose we are giving a search element as 100, which is not present in the array. We had searched throughout the array. And the condition which made me come out of this while loop is I greater than n or I equal to n. So that case becomes a else part and we have to return a -1. So in case the element is present in the array, it will return the index of the element, where we found the element. And if we are not finding, it will be returning -1. That is what we had given as the output. Expected output is either index number or -1. If number is present, it will return the index number. If number is not present, it will return the -1. So this way we can write the algorithm. This is the proper way of writing an algorithm. We have to write the algorithm name for which the problem is the problem for which the solution is written as an algorithm, expected input and output, and then you have to indicate the steps: step 1, step 2, step 3, like that. Okay. So this is what is the linear search. Now, in order to learn about some terms which are pertaining to the algorithm, as I told before, the best algorithm, in order to find the best algorithm, there are certain terms which you have to understand. Some terms like complexity and all. So in order to make it simple, I have first taken the example of linear search. There are different, if suppose you are giving different inputs for running the linear search program. Suppose I gave the same set of numbers and I gave the search element different in each case. Got it? You see this, all these three arrays are having the same set of numbers. And this is an array with the starting element with the index number 0, which is the first element in the array, 22, last element is 40. In all the three, I am giving the same set of numbers. But each time the search element given is different. Suppose in the first case, search element S is given as 22. How many times I should be? What is the first step for checking? I will be checking whether the search element is equal to the first element in the array. Got it? We will be checking whether the search element is present as the first element. How to check the first element? Suppose the name of the array is A. How to check the first element whether it is equal to the search element? Meenakshi? Meenakshi?
A of 0 is equal to 22.
With the variable name, if you are doing A of 0, whether it is equal to S, right? S is equal to 22, right? So now what will happen? What is A of 0? A of 0 is 22 and you will find it is equal to 22. So you found the search element in the first position. How many comparisons you did? You found the element in the first position itself, right? Meenakshi, how many comparisons you had to make?
One, ma'am.
Only one, right?
No. Like you will compare with every element in linear search.
No, in linear search, if you find, no, you will just exit from here, right? In the previous algorithm, you see, that is a logic if you are not finding, right? If you find at the first location, then you can exit from there. That's what you wrote the algorithm, right? In the previous example.
Yes,
If
ma'am.
you find A of 0 is equal to S, then this is not equal to, will not be satisfied. You will come out, right? So if you find the element in the first position, you will return the index number and then exit. That's it. That's why we gave the logic like that. So if you find the number, search element in the first position, you will be returning the index number as 0. If you want to return the position, 0 plus 1. That's it. So how many comparisons? If I'm indicating C as a comparison, how many comparison we did in this? We did only one comparison. We did the comparison A of 0, whether it is, compare means what? With the double equal to, no? Double equal to is for comparison. A of 0, whether it is equal to S. A of 0 is 22. What is S? S is also 22. In the first comparison itself, we got that it is equal. So only one comparison we did in this example. Understood. Now suppose in the next time when I'm running with the same set of numbers, if I'm giving S is equal to 40, how many comparisons should I make? Where is the search element found? Search element is found over here as
Last,
the last.
ninth,
So how many comparisons? You see, we will start with the first element.
8.
It is not the first element. Then second, third, fourth, fifth, sixth, 7. How many comparison? You are telling 8 or 9? 9 or 10?
8, ma'am.
1, 2, 3, 4, 5,
9.
6, 7, 8, 9, 10. Again, you have to compare. No, the last element also you are comparing, right? Then no, you cannot just assume after comparing the how many elements are present in the array. Nidin, how many elements are there? What is the size?
10.
10. Got it. And if you are doing only 8 or 9 comparison, it will go only up to 37. 8 means it will go only up to 87. 9 means it will go only up to 37. You should compare all the elements. You cannot just assume it is present in the last position. You will be again comparing S of 9, right? S of 9, whether it is equal to, whether it is equal to S. S of 9 is 40. Then only we will understand whether it is present in the array. Suppose I gave one number S equal to 100. What you will do? How many comparisons will be there?
11.
No, you will be doing only 10. 11 is not there, right? You will do 10 and then you will return that the element is
-1.
not present. You will return -1. That means it is not present in the array, right? You will, even if the element is present as the last element or if the element is not present in the array, you will have to make how many comparison? It is equal to the number of comparison will be equal to the size of the array.
Size of the array.
Right? That means n number of times. So here the number of comparison, in this case, number of comparisons will be the size of the array, which is nothing but 10. In the first case, you see, we did only one comparison, but in the second case, we did 10 comparisons. Got it? So this is the difference, this can be taken as a best case. When you found the search element as the first element, number of times algorithm was executed only once, one comparison only, which is a key operation over here. Key operation is comparison. Got it? The main operation is in the algorithm, we will tell one operation is a key operation. That is, it is not initialization of the variable and all. Our key operation is the comparison, right? Whether we are checking whether the search element is present as the first element. That is our key operation. That key operation of comparison is only done once. But in the second case, we are doing it how many times? 10 times. Got it? So this case in which we are doing the comparison only one time is named as the best case. Got it? I'll show you the definition later. This will be considered as the best case because we did only once and we found the search element in the first position. The second case where we did 10 comparisons, where we did 10 comparison will be taken as the will be considered as the worst case because how many comparison we did? We did 10 comparisons. So this will be the worst case. Even if the element is not present in the array or if the element is present as the last element, we were comparing how many times the size of the array. That means we are doing, in this case, we did 10 comparisons. So this becomes the worst case. Suppose the search element is any number between the best case and the worst case. That means if you are finding the element in the second position or if you are finding the element in the third, fourth, fifth, so we are finding the average of the usual cases, like whenever mostly when we execute, it may be sometimes the best case or maybe sometimes the worst case, but mostly when you are asked to run the program, you will be giving a number which is present in the third position or the fifth position, right? So you will be taking as a average case as the average of the comparison if the element is present as a first, second position or third position or the usual case, whenever we are executing whatever be the mostly executed positions. When we run, we will be just giving some number 67. Mostly I will be giving fourth or fifth position, right? So that is the usual case. So mostly the cases which we are giving, that is taken as the average case, but you cannot just tell average case as the 4th position or the 5th position. We will tell it as the comparisons required if the element is present at the first position. How many comparison is required if the element is present in the first position? Tell me.
1.
1. Second position, 2. Third position, 3. Fourth position, 4. Like that, we will find an average of the number of comparison for all the position from 1 to 10. So if the element is present in the first position, then it is 1 comparison. Then it is, if it is present in the second, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I didn't write it as 10. So all these 10 number of comparison, we are finding an average. How to find an average? You will add everything and then divide by the number of times, right? So you, for each case, there will be for each of the algorithm, you can find an average case. So that is nothing but the number of key operations executed for the most used cases. Always we will not give the best and the worst case, or you can tell it as the average of all the cases which are possible between the best and the worst.